Hey everyone, welcome back to another TxePrep video, and in this video we're going to talk about problem number 2 from the 2019 US Open Contest Bronze Division Milk Factory. So I'll just start by reading this. The milk business is booming, and Farmer John's Milk Processing Factory consists of N processing stations conveniently numbered between 1 and N-1 walkways, each connecting some pair of stations. Walkways are expensive, so Farmer John has elected to use the minimum number of walkways so that one can eventually reach any station starting from any other station. To try and improve efficiency, Farmer John installs a conveyor belt in each of his walkways, but he realizes that each conveyor belt moves only in one way, so now travel along each walkway is only possible in a single direction. Now it is no longer the case that one can travel from any station to another station. However, Farmer John thinks that all may not be lost, so long as there is one station such that one can eventually travel to Station I from every other station. Note that traveling to Station I from any other arbitrary Station J may involve moving through intermediate stations between I and J. Please help Farmer John figure out if such a Station I exists. So our input is that the first line is N, so in this case 3 would be our N. Then the next N-1 line contains two space-separated integers A of I and B of I, and that indicates that a conveyor belt moves from station A of I to B of I, allowing travel in only direction from A of I to B of I. So we're asked to output if there's a station I such that one can walk to station I from any other station, and we're asked to output the minimum such I. And if there isn't any station that works, we have to output -1. So let's just try drawing it out. So we see over here we have two inputs, 1 and 2, 1, 2, and 3 and 2. So that means 1 is going to go to 2, and then 3 is also going to go to 2. So that's basically what it means. And in this case, we see that our output would be 2 because from every single station we can reach this station of 2. And in order to solve this, I would say that we should use DFS because it's kind of like a graph problem, and we're traversing through different nodes in a graph. So that's what we're gonna do. So in this case, I'm going to include. Oh, sorry, no, this is my factoring out. My main CPP. I'm going to include fstream and use namespace standard. And I'm also going to include vector because I'm gonna have my adjacency list as a vector. So an if stream fin and I'm gonna call it factory.in, and our off stream is going to be factory.out. Alright. So what do we get? So we get the int n, and then we also get the int n, and then we also get these other two we get these other two inputs. So I'm going to create the integer n, and I'm going to create an adjacency list with which is in the form of a vector of int, and it's going to be called adjacency with a size of 102. Right? And then I'm also going to create an array called bool visited, which is also the size of 102, just to indicate whether we have visited a certain node or not, right? And then what I'm going to do is create our main function, int main, and in that I'm going to input n. Then for int I is equal to 0, I is less than n-1. Like we're now going to input the two a of I and b of i's that we see over here, n-1 I plus. And what we're going to do now is create two dummy variables, int a and b, and then input a and b. And then what we're going to do now is for the adjacents, normally if it was just a regular DFS and it wouldn't have been like a one direction traversal, what we'd have done is we would have done adjacents at a dot pushback b, basically inputting b into the adjacency list of a, and also the same thing for b. So instead of and we would input a into the adjacency list of b, right? But in this case, since it's only one directional, meaning that we're going from a to b, we want to put a in b's adjacency list, basically. So that's what we're gonna do over here. And now what I'm going to do is initialize the answer to just -1, like that. And then I'm going to create a for loop to simulate every single starting integer. Like we can start with node 1, node 2, or node 3. So for int start is equal to 1, start is less than or equal to n, and start plus plus. And in this case, what I'm going to do is initialize the entire visited boolean array to false. So for int I is equal to 0, I is less than 100, I is less than 100, I plus plus, and visited at I is equal to false. And actually, instead of 100, I'm just going to make the entire array, so it'd be less than 101. So it's false. And now what I'm going to do is do a DFS with that variable start. And in order to do a DFS, I have to make the DFS like function first. So I'm going to say void DFS int node, and then I'm going to visited at node is equal to true, and then for auto u in the adjacency list of that particular node, I'm going to do a DFS of that node, basically just recursion. And we're going to make sure before that the visited at that specific node, that specific u is equal to false, and then we're gonna, if that's true, then we're gonna do the DFS of u. There we have it, and that's basically our DFS function. And now what we're gonna do after that is create a boolean done is true, and we're gonna initially assume that our DFS was successful. But now what we're going to do is check every single value in visited of I and make sure that it's all true, that all of the values have been visited. And if that's not true, then we're going to make done, like this boolean done over here, false, meaning that that specific starting integer did not work out. So I'm going to say for int I is equal to 0, I is less than or equal to n. Wait, no, it'd be for int I is equal to 1, my bad. I is less than or equal to n, I plus plus, if visited at I equals false, then we're also going to make done equal to false. That's basically what I said before. And at the end, what we do is if it is done, then we know that that is our answer. So we're going to set our answer equal to the starting integer, right? And then we're going to break out of the loop to make sure that we don't continue on with other integers. And there we go. And what we can do after that is just simply print out the answer. So that would be how we would solve this particular problem. So let's just run it, and I have the input set up such that it works over here. And let's see what happens. So we get our correct output of 2. So now let me try submitting it and seeing what let's see what happens. So here I am about to submit the solution. So let's just see what happens. And we can see that it does work out, and we get all of our solutions correct. So basically, for this question, what we did was we just did DFS, a simple DFS on an adjacency list, except instead of having both of the integers, like for example, both the integers 1 and 2 going to each other's adjacency list, we only had it such that integer A went into integer B's adjacency list, and that was kind of like the distinctness for this problem. So there we have it for this question, and I hope to see you guys in the next video.